Hey everyone, welcome back to the channel. Today we're going to understand one of the most important and beginner-friendly topics in machine learning, linear regression. Don't worry if you're new, I'll explain everything step by step, with clear intuition. Before jumping into linear regression, let's quickly recall what machine learning is. In machine learning, instead of writing rules manually, we give data to the model, and the model learns patterns from it. Linear regression is a supervised machine learning algorithm. That means we train it using labeled data. Its main job is to predict continuous values, like price, salary, marks, or temperature. Let's take a simple real-world example. House price prediction. If we know the size of a house, we want to predict its price. Linear regression helps us find the relationship between size and price. In linear regression, we assume that the relationship between input and output is linear. When we plot the data points on a graph, they roughly form a straight line. This is the heart of linear regression. The equation equals plus. Here decides the slope of the line and decides where the line cuts the minus axis. The slope tells us how much the output changes when the input increases by 1 unit. A higher slope means a steeper line. The intercept is the value of y when x is 0. You can think of it as the starting point of the prediction line. The model starts with random values of m and b. It makes predictions, checks how wrong those predictions are, and then slowly adjusts the values to reduce the error. The difference between the actual value and predicted value is called error. Our goal is to minimize this error as much as possible. To measure error, we use a cost function. The most common one is mean squared error. It squares the error so that bigger mistakes are punished more. To minimize the cost function, we use an optimization algorithm called gradient descent. It slowly moves towards the best possible values of m and b. Linear regression is simple but powerful. It builds a strong foundation for understanding more complex machine learning algorithms. However, linear regression also has limitations. It doesn't perform well when the relationship is non-linear or when there are extreme outliers. To summarize, linear regression is a supervised algorithm used to predict continuous values using a straight-line equation. Like the video, subscribe for more ML content, comment your doubts.